Good morning, class. Electric current. What is electric current? Electric current is the flow of charges or flow of electron from higher potential to the lower potential in an electrical conductor or a wire. So from higher potential, which is positive, to the lower potential, which is negative. That's what we call conventional current flow. Now, consider this. This, this is parallel. Of course, when you have a series connection, you can have it like this. The total resistance, this one is R1, R2. We are going to have R total give us what? R1 plus R2. But in case you are having parallel connection like this is a parallel connection. This is your R1, this is your R2. So your R total there is going to be 1 all over R total, giving us what? 1 over R1 plus 1 over R2. From here, you find the SDM 1 over R total, gives you what? R1, R2 becomes the LCM. So you have R2 plus the R1. When you find R1 goes there, you have R2 times 1, you have that. Now, when you cross multiply, you are going to have R total will give you what? Product over sum, that is R1, R2 all over what? R1 plus the R2, or R2 plus R1. So this one becomes our total resistance. Now, looking at this question, consider the circle diagram, calculate total resistance. So our total resistance is R total, which is what? Product over sum then. So we are going to have what? 3 and 6 all over what? 3 plus 6. This gives us what? 18 all over what? 9. So our R total at this level is going to give us what? 2 ohms. That is the unit of resistance. Ohms. Ohms. As units of resistance. Now going forward, total current I. How do you get current I? Total from V, which is called to I from the Ohm's law. So from here we get our I to be equal to V all over R. So at this level we are talking of V total all over R. Our V total is the EMF, the electromotive force, that is the sum of all voltage drops in the circuits all over what? R. So how do you get that? We are going to have what? 12 all over R, which is R total. So this one represents the R total now in that circuit, which is our 2 all over 2. This gives us what? 6 amps. That's the unit of current. 12 volts all over what? 2 ohms give us what? 6 amps. That is the answer. Now going forward, we have to find the current in each of it. If the current I gets to this, current one, I1 go to this, then I2 go to this one. So actual current will say I equals to what? I1 plus I2, which implies that I minus I1 minus I2 will give us that is actual current law. So going forward, we have to calculate the current in each resistance. So since we must take note of one thing, the same voltage flow in a parallel connection for different currents. You can see different currents when they get to this they differ. But when you are having series connection like this, so we have the same current will flow, but different voltage. But every electric current must be in parallel connection. So going forward, current high one there. So we're going to have I1, R1, because what? The same voltage will flow, or 2, because of V total. So how do we get our current high? I1 multiplied by R1, which is 3, because of V total, which is 12, because the same voltage flow. So we're going to have I1 equals to 12 all over 3, which gives us 4 volts. Going forward, I2, R2 must give us V total. So I2 multiplied by R2, which is our 6 volts, plus what? 12 volts. So we are going to have I2 equals to 12 all over 6, which gives us what? 2 amps. So this one gives us amps. That is the current flow. Now to calculate the current flow, the current that flow in the circle, which we've already calculated here, we can check it there. I1 plus I2, because we say I is equal to I1 plus I2. Looking at it, our I is going at 6. So we can say 6 amps is equal to I1, which is what? 4 amps plus 2 amps. So this is already telling us that the Kirchhoff current law is correct. That is the current that flows through a junction, the junction of the circuit, the algebraic sum of the current must be equals to 0. Thank you. So if you have any question, please, we'll feed you back. Thank you.